So first of all, we would like to finish the Iterator pattern. So that will be covered by your lab test this Friday. Let me remind you, there was an in-lab demo on Friday last week. So you can refer to the recording for that. That might be useful. Okay. Let me just summarize what we have done. Basically, two cases for Iterator patterns, specifically from the supplier's point of view. And then we talk about very briefly about the client's point of view, which you're very familiar with already. Okay, so let me just use a design diagram to explain to you. And you'll find more details in the tutorial videos and the in-lab demo for the coding. Basically, every time if you want to use an iterator pattern, that means you really want to use the across keyword, the construct from the client side. If you want to support that, you have to implement one way or the other from the supplier side. The easy case would be, let's say, the card class that we talked about from last week. Okay, let me just draw where it is. Imagine that we have a card class to begin with. In the card class, we actually got an attributes, maybe private, orders of type array of order. Okay, let me just write it in brief form. That's how it started with. In order to support this particular class for iterator pattern, let's just get the context right. Let's highlight the important client-supplier relationship first of all. You can see for the orders is an array of order. So now we want to show that direction for client-supplier. So that means card is the clients and the supplier is one of the base library classes for collection, which is the array. So I will simply put orders over here. Okay, so far so good for the client supplier. And now, in order for clients of the card, in order to say, I want to say across card, that's what I want to support. I want to inherit for card from Iterable. That's what I want to do. So step number one, for the easy case, I need to inherit from the Iterable class. And now, one thing to remind you, the green one over here, the two classes over here. So these are the iterator pattern. Okay. Let me just write it down here. So these are the iterator pattern. And any classes which want to support the iterator pattern, they have to somehow do something with these two classes. Okay. Now, in the easy case, what we really want to achieve is, from the pattern, it tells us you must support the new cursor feature if you inherit from Iterable. Now, how do we support it in the easy case? In that case, we can simply get it for free because you can see the card class, let me use a slightly different color here. The card class is over here. That one has a client-supply relation here, which points to array. Every base library is guaranteed to have already implemented the iterator pattern. So that means we can go directly through the new cursor over here. In that case, we got one class that is a descendant class of the iteration cursor. So we can get it automatically for free. Okay? It's a very quick sketch about the idea. From the diagram, basically, as long as somehow from your particular application class, if you can somehow have a path into one of the descending classes for iteration cursor, then you're done. So easy case, it's just like that. Okay? Any question about the easy case? I will talk about from until loop in just a moment. You're more talking about the client side. Now I'm more talking about how you can implement the card class. We'll talk about the client side. I do want to mention from until a little bit later. Yes, iterator pattern is not specific to iPhone, so the way you support iterator pattern in Java or C# will just be the same. They have some predefined classes similar to Iterable and iteration cursor. You just have to inherit from them. And it will also be similar, you have the easy case and hard case. Okay? One more thing I want to draw your attention. Okay? One more thing. When you actually study this particular pattern, notice that you can see from the pattern level over here, we have new cursor here, which is star means deferred or abstract. It's unimplemented. On the other hand, once you have implemented the iterator pattern, you will see new cursor here is plus, which is effective, implemented. So notice the difference between these two arrows at different levels. One is at the pattern level, the other one is at the implementation level. Okay, that's about the easy case. Let me move on to the hard case, which you might more often encounter. The hard case, the principle will be the same. You want to somehow find a path going from your class, let's say book, into one of the descendant classes of iteration cursor. What if you have no such descendant classes for your specific need? Create one yourself. That's the principle. Okay? Let's see how we can draw the diagram for this. Again, let's start with our example class called book. Okay? I used that also in the link lab demo. Let's say we have a class called book. And now in this case, we are having, rather than just one single collection, we got two collections. Let's say it's book of G, and G here can be any record type. In that case, we're going to have names, I'll say NS, is going to be of type array of G. Oh, sorry, string. Array of string, and also records is going to be, let me just make it a little bit slightly different. Let's say it's linked list of G, the record type. Okay? So now, how many client suppliers should I draw over here? Possibly two. So it's more sophisticated than the easy case. Let's draw that first. Let me draw, first of all, the names array, which means I have a client-supplier relation to the array class over here. And it's going to be names. Okay? And then it's going to be array of, basically, the name string. Okay? You can also put some detail over there. Okay? And then the second one is going to be a linked list. So which means from the same class being the clients, I have another supplier class here. Okay? Another client-supplier arrow. That should be records. Okay? We got two client-supplier relations here. Now, the same goal. I would like any clients of the book to say across the book directly. In order to support it, I have to implement the book from, I have to inherit the book from Iterable. Let's follow that very first step. Now I'm going to say book is going to inherit from Iterable. Okay? As soon as I do that, now I have the obligation to implement this particular new cursor, which should be at a pattern level, should be iteration cursor. Okay? So now I have stock, basically, because from names, I have array which can return one new cursor for me. From records, which is linked list, I have another new cursor for me. However, I'm only expecting a single new cursor. How can I combine them together? That's why I'm stuck. Okay, that's why I called it a harder case for you. The principle would be if you really cannot simply make use of the new cursors, multiple ones, that's supported already by the base library, you have to create a new class by yourself. Okay? So what we should do is, let's draw that here. So this is the most important part when you do the hard case. Number one, I'm going to simply do a new class over here. Okay? I'm going to call that maybe my cursor. And then I'm going to make it, first of all, inherits from this particular iteration cursor class. This is an inheritance error, which means I will be obliged to implement these three features, right? So now it means I need to implement item, I need to implement after, also I need to implement fourth. So that's why I put the plus over here. As you can see, I got to implement them. For details of implementing that, you can refer to the tutorial or the in-lab demo. You will see more hints from there. One more thing to say. Now, how do we know this is really working? This is really working because this another client-supply relationship you want to draw. So which means from book, right now, for the new cursor, it's now going to return this particular type, which is my cursor. Okay? So now I'll just say new cursor over here. Okay? That should be plus. And now notice the difference between the two cases. In the hard case, you can see over here, the new cursor is of type of a class that inherits from iteration cursor, and we created this class. On the other hand, in the easy case, the cart actually simply returned a new cursor that's actually supported by one of the collection library. And of course, that's also a descending class of iteration cursor. So in both cases, the principle is the same. You want to return an iteration cursor objects. Okay? It's a very quick summary about the two cases for implementing the iterator pattern. In the lab test, you have to judge which one you need. Okay? Question? So in the lab test, you have to judge whether you need to create a new cursor class yourself, or you can simply reuse the new cursor that's from the base library. So the fundamental difference between the easy case and the hard case is as follows. In the easy case, you can simply reuse whatever new cursor that's available to you already from the base library. On the other hand, for the hard case, you cannot really use them together. You have to somehow create a new class for you for that particular purpose. So that's a quick response to your question. Not necessarily number. Think about the principle. If you just cannot use all the new cursor that's already available to you, create a new iteration cursor class yourself. Okay. Yes. I cannot, sorry? Correct. So you cannot simply reuse the two classes, You cannot simply reuse the new cursors from these two classes directly. So that's why you create a new class. Yes?
Is it better practice to do the hard case solution just in case the implementation changes in the future?
It's a very good observation. Very good. So the question was as follows. Let's say, of course, in the hard case, when you had no choice, you have to create a new iteration cursor yourself, for sure. Okay? What about, let's say, if currently my implementation allows me simply do the easy case, which means I can simply say orders the new cursor, let's say. Is it okay if I say I still create another iteration cursor class, just for now, say my cursor, and make everything to work? So that will give you the flexibility that, say, later, if you change your implementation over here in such a way that you have to use an iteration cursor class, it's already there. Yes, that's a very good observation. So guys, it's a very good feedback you're giving. So let me just repeat that. Let's say even though currently I can simply solve the problem by saying orders a new cursor, that's the easy case. However, I can still choose to create another class over here that's called a my cursor. And then I'm going to implement, of course, item, after, and also forth. All the inherited feature from iteration cursor. Of course, there will be inheritance relation here. Let's put it first, and then I let the cart return this particular type over here. That'll be new cursor. Of course, the implementation will be very easy in terms of how I implemented my cursor. But that gave me the flexibility that, let's say later, if I decide to change the orders from array into some very special data structure, which simply doesn't have the new cursor, in that case, I can simply go to this particular class and change it accordingly. Yes, I think that's a good observation. Yes. In the lab test, as long as it works, I don't care which one you use. But it should be quite obvious in the lab test which case you should really adopt. All right. So this page here simply just gives you a little bit more detail just about if you create your own iteration cursor class and you want to make sure you have to put item, after, and forth, right? So that's something you already learned from the in-lab demo or the tutorial video. Okay, that one's easy. I don't need to bother you with that. Now, I would like to summarize how the iterator pattern will work at a runtime before I move on to just more example from the client side. So the idea about iterator pattern is to really for information hiding. You want to hide from the clients any underlying data structure that's supported by the supplier, which might change often. Whenever the supplier changes the data structure, the client should not be affected because all they use is a cross loop. That's all they use. Okay? Let's see how we can make this think about it, and then we'll see example. Let's say here we have a new class called array map. Let's say that's my supplier. Okay? That's my supplier over here. And then privately, I have names and records. So these are supposed to be hidden from the clients. I'll just say hidden. So which means any external clients, if they want to get access to my array map, they simply just cannot get access directly to names and records. What they have to do, if the iterator pattern was supported, is as follows. First of all, we had to say array map inherits from the iterable and whatever type over here. So remember I mentioned briefly in the in-lab demo. Whatever generic parameter type you have to put over here tells you the type of item to be retrieved by the clients. So currently I'm saying when the client is trying to use my array map, when they say across array map, so let me just say that again over here. If I say across let's say AM is of type array map, the supplier type. Okay? And then I say is, let's say maybe some I over here, some item. And then I can use maybe, let's say loop, for example. So now the question is, here, whatever type you specify over here, in this case tuple, is going to correspond to this particular type for I over here. Okay, that's something I mentioned previously. So that's really affect your choice about how to instantiate a generic parameter for iterable. Okay, okay, let's go a little bit further. At the runtime, what's going to happen? You can think about as far as the client is concerned for this particular array map class, they only worry about this particular public feature, which is called new cursor. That one is public. So when the client is trying to use this, think about the following scenario. So let's say in the client's code, they say maybe AM of type array map. Okay, I'm just writing in brief form, and something over here. Okay, as soon as I say this, I definitely cannot say am.names. Of course not, because it's private, so this will not even compile. Okay, but now I can definitely say something like this. I can say across am is something, and this will correspond to the type of this particular generic parameter, as I said. Okay, and then I can do something with I over here. Okay, so now thinking this way, because new cursor over here. Oh, let me say one more thing. As we'll see, the way the across work is really by calling some iteration cursor features for you implicitly. Okay, namely, if I say, for example, am dot new cursor, this is something that client can definitely call. In that case, it's of type iteration cursor. Iteration cursor. And we'll see example about using this in a front until loop. We'll see that in just a moment. Okay, so this is the only thing the clients can call. Let's say the client say am.new cursor, so they're getting this particular object over here. That's the iteration cursor. And for that particular iteration cursor, what public features can the client call? And if you remember the diagram here, for iteration cursor, you can definitely call item, after, and forth. That's what a client can do implicitly, right? So now in this case, every time when the client says, I want to get what's the current item that's pointing to by the cursor, what the iteration cursor will do is to say, based on where the cursor is, maybe currently it's pointing to the first element. So it's going to return the first element here as a tuple. That's for the first iteration for the across. Okay? And then if the client say, now I want to move the cursor forth by one position, so what they will do is, under the hood, is going to change the pointer to the second position here, and then the second position over here. And now if I say new cursor.item again, it's going to give me this particular tuple instead. Okay? So the clients never get access to the underlying data structure. What they will get is a tuple at a time. Okay? So this is really something you want to summarize to yourself at the end for iterator pattern. We are hiding the underlying data structure. Of course, names and records, they might change to be from array into linked list or maybe tree or hash table. Okay. Any questions? Yes?
Are they giving the actual address of the tuple, or are we creating a tuple within tuples using reference address?
Okay, you're basically talking about, okay, let's say if I'm currently returning this element as a first element as a tuple, and this is the first element of tuple. It really depends on what kind of a security you want to achieve. If you can assume any potential clients is not going to do something bad to the element here, in that case, you can definitely just return a reference. On the other hand, if you cannot assume anything, you better do a deep twin. Right? It depends. But I would say, what about in the lab test or in the lab or project? I would say, unless we tell you that you have to do a deep twin, otherwise you don't have to worry. We can assume we don't have that kind of security issue. Okay? Which one? So every time, so this is an iteration cursor object, right? That's returned by new cursor. When the client say new cursor.item, what it will do is, first of all, it's going to follow the pointer of the current cursor position. Maybe currently the cursor is pointing to the second element here, and also the second element in the second data structure here. And what they will do is it's going to return them as a tuple. That's what they will do. So it's really up to your iteration cursor implementation. How do we know? You will point to the above and below like this. Okay, so you can see values 1 is pointing to here, and values 2 is pointing to here. So exactly how to set this up. So now I'm just summarizing how the iterator pattern works at the runtime. Exactly how this works, you have to follow the tutorial video to see how to do the coding. I assume you have done the coding already, so now I'm showing you. You may want to do more coding on the iterator pattern. Okay. Mm-hmm. Yes? Good question. The question was, if the clients was simply just, let's say, they just want to use a cross, do they ever have to call forth? The answer is no. But we got 2 versions that the client can call. Oh, I'll show you. Okay, bear with me. Okay, any question about this particular diagram here? Okay, this one is just for conceptual confirmation, right? Of course, I assume you have done the coding already. Mm-hmm. Yes. It's a tuple and string and G, yes, correctly. Correct. Tuple is not a math models class, it's just an IFO-based library class. You can definitely use it in the lab test. Yes, the principle is you don't really use any math model objects in your implementation, but in the contracts, feel free.
But we don't have to. We have to use math model.
It will be quite clear to you during the lab test, basically. Yeah, I think for the lab test, in the pre and post condition, you must use the math models. You must, yeah. Okay. Okay, so now let's go on with, okay, there are some exercises for you. You can see how to draw a bond diagram and also to follow the tutorial video. I'll leave you to that, okay? So now let me just talk about briefly. Let's say the supplier has already implemented the iterator pattern. So now how can we use it? But just simply use a cross keyword. And you have seen that already. I just want to highlight some important stuff, and then we can move on to the next topic. And what I will do is I'm going to just move on to my iPad and show you example by example. Okay. The first one. Let's say over here we have a class called checker. Okay. And then we have a object over here called collection. And then you can see we only declare the type for the supply being iterable. Okay. So there is something I want to mention. There's a design principle. That's also mentioned in the slide. Let me point you to that. Okay. Step number 1 here, obey the code to the interface, but not to the implementation, meaning that when you declare the supplier type, it ought to be as general as possible. In the case of the iterable pattern, the most general type you can declare for the supplier is iterable. Okay. So now let me show you back to the example here. And you can see for the collection here, apparently, iterable here is an interface type. So what this will be very flexible because when you actually create objects for collection, you got lots of possibilities. Any subclasses for iterable can be used as a dynamic type for collection. Can be array, can be linked list, or it can be card. Okay, whatever class. Okay, let me just write it down here. Dynamic type of collection, which is the attribute over here, can be any descending class. Any descending class of iterable. Okay, that's the advantage. On the other hand, let's say this. If I didn't follow this particular principle, let's say I simply put, rather than iterable, if I say collection here is of type array, let's say, as a supplier type, array of maybe integer. In that case, I got rid of the flexibility. Now, if I want to create a collection of objects, what can be the runtime type for me? Only array, I'm afraid. Right? It cannot be, because the only descending class of array is just array. I don't think there are many possibilities you have. On the other hand, if you chose this particular option over here, it gave you many more choices. It is a principle, small principle you want to bear in mind. Okay, that's the only thing I want to mention. And now, because collection is simply iterable, so I can simply use a cross loop. So you can say across over here, collection already, right, directly. And then, what would be the type for item? Integer, because that will be exactly the generic parameter type you instantiate over here. Okay, that's about the first example. And the second example here, let's say we choose list. In some way, this is also obeying the principle, because list is also a deferred class, meaning it's like abstract class. So this really gives you the possibility of the dynamic type can be linked list, for example, or any descending class. There are several. Any descending classes of list. Okay. And then in this case, we can simply, for the list, you can simply go across its indices, for example. You want to see if this list, maybe the list is sorted or not. In that case, you can use go across the indices, and for the list, you can definitely use a square brackets notation, right? We talked about it already in the lab. Okay. Any question about these two examples? The main lesson is, if you declare the supplier type to be something that's iterable, you can use a cross loop. That's the main message. Yes.
Say for the account, instead of this including an iterable,
Yes.
then would it compile back to the cross loop?
It's a very good question. The question is as follows. Let's say from the client side, if I declare, supplier, that's what I meant. Let's say for the, actually, you know what? I think just client would be fine. Okay, just make it as simple as possible. Let's say from the client side, we have the following code. Let's say we have collection, and then it's simply iterable. Let's say each element will just be a string. Okay, this is how we declare the attributes. How do we create that? So now, if I simply say creates, I need to give a dynamic type, because iterable is simply deferred. It's abstract. It cannot be used as a dynamic type. And then I can say collection. Let me just write, and now I'll fill in this place in just a moment. Collection dot maybe make, for example, or make empty, doesn't matter. So now what can I put over here? Anything that's iterable. I can put, for example, array. Array of maybe integer. Or I can put linked list of integer. So both are okay, because both are descending classes of iterable. Of course, if you chose the array option, you gotta say make empty, right? If you chose the linked list option, you gotta just say make, depending on which one is available to you. I think you might be right. So here, I think I meant to say string, because I talk about string here. Good. Question?
So does this choice is somehow related to a single choice principle?
Does this actually somehow relate to the single choice principle? How would you think that's the case? We're just guessing. Okay. It seems to be no. Single choice principle tells you if you change something, you don't have to modify multiple places. But now this is just about the flexibility of creating dynamic objects for your supplier. So now this is, again, if you actually declare the supplier type to be of iterable, so that means the dynamic type can be any of the descending classes of iterable. In this case, you got many choices, not just array and linked list, anything that's iterable. On the other hand, if I actually put maybe just array over here, to say array of string, in that case, how many options do I have over here? Not many, right? Just giving me more flexibility, basically. Okay. Let me go back to the original question. Okay. I just wanted to mention something before I talk about it. Let's say the client they created this collection objects. Now, remember that iterable over here is so-called static type. And later on, we're going to review about inheritance. Of course, we're going to talk about static type versus dynamic type. We'll talk about it a little bit later. But remember, iterable over here is a static type, meaning that the range of features you can call upon collection depends on what's defined in the iterable and what features are available in iterable. I'll let you cheat. According to the diagram here, if the static type is iterable, what can I call on the objects? New cursor. No more, no less. That's the only thing. Okay? Keep that in mind. And then let me go back there. If the client now wants to do something like this, they want to say across collection is maybe some I, and then loop. I'll give you both options, okay, and see which one might work. So now, what would be the type for this particular I? String? Integer? Well, I here should correspond to whatever parameter it was instantiated by, right? So that should be a string. Okay, I deliberately choose I, so don't think that should be integer. Doesn't have to be, okay? So that's the first option, okay? That's fine. Let's try the second one that you just asked me, okay? The second option goes like this. Let's say I want to go for across. Okay, sorry, let me write it better. Across, I want to across maybe indices. So now 1 until, for example, collection account, for example, is I. And then loop over here, and then I might say collection at position I, and then etc. Okay? Consider this fragment over here. Is it going to work? Good. Why not?
Because collection.count is part of, like, this part of the methods in Iterable.
Exactly. That's correct. It wouldn't even compile because the following. Does not even compile because the count over here and also the indexing notation implicitly, collection with a square brackets is calling collection dot item I. But item is also not defined in the new cursor. Oh, sorry, in the iterable. Okay, first of all. And intuitively, this makes sense because when you actually declare this particular iterable type, you're saying any descendant clauses can be used, right? When you actually say collection account and then go from 1 until it, you're assuming that the collection is linear, but it doesn't have to be. So what do I mean? For example, let's say if this is an iterable interface, right? That's an iterable, that's deferred. Possibly, conceptually, there is a branch of the subclass that's simply just linear, which means you can refer to some particular position, right? And one of them is simply array and also linked list. However, there might be just another branch over there that could be non-linear. For example, it might be a graph and might be also maybe a tree. In that case, using 1 until count and using item over here doesn't make sense because for non-linear data structure, you just cannot refer to their position, right? Just something to keep in mind. Okay, good question.
Good question. So is that just theoretical link list you can use the square bracket like position, right? Even though, like, in Java, like, you can't access like 0 or 1 times this link to go to first element all the way to the end, right?
So if I understood correctly, of course in Java, the only data structure you can use square brackets, right, in Java is when this is actually an array. Yes, I agree. But now, when you learn every different language, they got some language-specific feature that you have to get used to. In IFO, not only that this can be array, but also this can be any linear data structure. Okay, so they just support it. However, of course, if you say you have a linked list, and then I want to go to maybe position I, so this is not very efficient because you have to start a cursor and count where is the ith position. But that's okay, just for design purpose.
Same thing as Java. You have one all the way to
Yes, absolutely. You got to go from the beginning until the particular position.
I think I missed one correct to do it.
Oh, yes. So in the previous example, let me summarize for you. Okay. In the previous example, here's the point. When the clients declare a collection to be of type iterable, that tells you any feature that you can call upon collection is defined in iterable, which is only new cursor. Okay? In that case, if you say the cross loop, that's simply fine. I'll explain what exactly a cross loop does in just a moment. However, this particular version here is simply not going to compile because the count is not available in new cursor type, in the iterable type. And also the square brackets or item feature is also not defined in the iterable. That's why they wouldn't compile. It's quite a common mistake actually, because if you somehow declare a collection to be of type iterable, and then you try to use this particular version over here, make sure you know why it wouldn't compile. Okay? For the reason I just explained. Okay.
So there's no correct way to do it.
Oh, for this one? No, I'm afraid not. Yeah. So the reason that there will be no general solution for this particular one, simply because when you say it's iterable, you have no idea at the runtime what's really passed as runtime objects. It could be something that's simply graph or tree. In that case, there's no way for you to tell, right? Yeah. Okay, so let's see the next example. Okay, the next example is also quite easy. This one just I want to point to you. So let's say we got a bank class, and now we say list over here. So now we really want to refer to positions in the account in order to check for duplicates. Let's say the post condition I want to write is to make sure there's no duplicates in terms of the accounts in the bank, for example. Okay, so that's why I have to use list. Cannot be iterable in this case, because we want to refer to positions in order for checking duplicates. Okay? That's the only thing I want to mention in this example. And in order for you to write this, I will give as an exercise for you. Translate this for all into across. And one thing to mention, that could be something you tried but failed. Mathematically, you say for this particular for all, you got I and j, two dummy variables. You might be quite intended to do the following. To say across, maybe from 1 until maybe accounts, let's say. And then you simply say is I, j. It would be very nice if this was supported, but currently no. So for every across loop, you must have exactly just one dummy variable. If you want to have two, you want to have nested across. There's no way around, I'm afraid. Okay? So this is not going to compile because each across can only be bound to a single dummy variable. Okay, it's a quick note. Don't do it in the lab test. Okay. Okay, let's see the next one. Okay, that's the one I want to mention. Okay. Let's say now the clients, they declare something that's iterable. Okay, notice that here we say accounts is iterable. So that means the only feature we can call it is collection.newCursor. That's the only one. That's the only feature we can call. In order for you to use new cursor, there are two ways. What you have been following so far is the across loop. That's the easy way. You don't have to worry about item. You don't have to worry about after. You don't have to worry about fourth. But you can also do it when you have to worry about them. Okay, that's the second version. Let's take a look quickly. And the way this works is more like how cursor works in your 2030 or maybe your 2011 or 2031 when you talk about cursors, right, for data structure. The way we do it is very easy. Basically, you say that you use a from until loop over here. To initialize, you have to say, first of all, you want to get accounts.newCursor. Okay, just return the object, first of all. Okay, and this one, by default, is going to set the cursor to the beginning position. That part can be done by you, will be done for you. Beginning position. After that, you're going to say, I want to run the loop until the following condition becomes true. After simply, think about this. If this is my collection, for example, right? This is my collection. The cursor initially is going to point to the first elements. Every time, if I say fourth, it's going to move the cursor to the right by one position, okay? But what if the current position is actually pointing to the last elements? If I say fourth over here, it's going to move just after the list. In that case, after will just be true. It's exactly after the last position of the list. That's why it's called after. As soon as after is true, we're going to exit from the loop. And then make sure every time you have to move the cursor forward. Without this line, what's going to happen? Any idea? Infinite loop is as if you didn't put I is assigned to I plus 1 for the for until loop. Okay, be careful. Should you choose to use this option here, make sure every step is followed. Infinite loop. And then every time inside the loop, you can simply say the item over here. Any question before I try to do some comparison for you for the final message? Question? Yes, IFO language will be compiled into C code for better performance, yes.
Are you going to be looking later in the course about reading the code in C or something? I don't know.
Will you later have to read the code in C? Fortunately, no. No, you don't have to. No. Basically, that's only the job for the compiler. So whatever C code that's generated, you assume the compiler has done the correct job. So they're going to generate something, whatever you mean to happen in IFO level is going to happen at the C level. That's something you can assume. So you never have to touch the C code, never ever.
So you can always read items.
You can, that's why we said, when you, for example, when you actually back up your projects, you don't really have to back up the ifgens because ifgen can always be generated. Yeah. Oh, it's pretty much like you don't have to keep the .class files for your Java projects, right? Because .class file can always be compiled by your Java compiler. Similar issue. Yeah. Yes.
So when you declare the recursive, you don't have to recurse start.
Yes, correct. So the question was, when I actually get a new cursor over here, as I said, it will just set the cursor to the beginning position right away. So you don't have to say, so let me just make it very explicit. So here you don't have to say cursor.start. Nope, not necessary. It's a good question. It shouldn't change anything. Give it a try and see what happens. I don't think you would change anything. But if you don't have to write it, why would you write it, right? Yeah. Mm-hmm. Yes?
Sorry, one thing is, normally you do counts by making the square brackets, counts, square brackets, whatever.
Yes.
I'm kind of confused. Like you said, Iterable doesn't really allow you to do that. Like two references. Like it doesn't allow you to reference the account values.
Oh, you're talking about this guy over here, right?
Under the view part.
Oh, yeah, exactly. Oh, that's a very good catch. So when I say accounts one over here, I absolutely agree with you. So that means my code got some typo. Good for you, okay? I will change this and then re-upload the slides. Very good, okay? So guys, only this line is not worth your attention, but the rest is fine. Okay, but this one I'm going to change it, okay? You cannot use the square brackets when it's iterable, as we just said, okay? So this is not okay. Thanks for the catch. I'll change it, okay? So the error your colleague just caught was like this. The accounts was declared as iterable. So that means the only thing can call is new cursor. But now I'm using the square brackets over here, so that should not be allowed. So that should be a compilation error. So that's a typo. I'm going to fix it. For the iterable, it does not support any square brackets notation. Yeah, you can only call new cursor. Yes, correct. I'll fix that. Good. Okay, so now I want to show you one more thing. Okay, just as a comparison. Okay, so now let's say the following. Okay, at the client side, if I say again collection, let's say it's iterable. And then let's say string, okay? When the client say the easy way, they can say across collection is, and then C, for example. Maybe say item. Of course, in this case, item will just be of type string over here. Just notice the correspondence. And then we can say loop, and then end. So this particular construct over here is going to be, think about its equivalent to the following from until loop. Just show you. Equivalent to this. From until loop and end. Okay, let's take a look. So now in the local variable, let's say, I simply declare, let's say, C for cursor. Okay? C is of type iteration cursor, and then also string. And now I can say C is assigned to collection, okay, I'll say COL, collection dot new cursor. And as I said, it's going to bring the cursor position to the beginning, right? As I said, you don't have to say dot start, you don't have to. And then until cursor dot after. And then loop, I can say C dot item over here, and then I can say C dot fourth over here. Okay, so these are the things you have to do if you do it just by yourself. Okay, just to mention quickly. And one more thing to mention, this is why if you write this particular loop in a slightly different way, if you say across collection as, okay, notice I chose a different keyword over here, C. And now you can say loop and also end. You can think about the C over here is exactly the C iteration cursor over here when you use the S keyword. In that case, you had to say C.item in order to get to the string elements. Yes? Can you actually do C.fourth over here? Okay, let me say this. Okay, let me just move this a little bit, give me a little bit more space. You're asking the following question. Let's say C here is basically an iteration cursor of string. Okay, first of all. You were asking if I can write, for example, let's say after C.item, can I write C.fourth? The answer is yes and no. Yes, you can do it, but no, you shouldn't do it. Why? If you wrote C.fourth over here, remember implicitly the Eiffel runtime is also going to call C.fourth. That means every time you got C.fourth twice for each iteration. So that's not going to get the behavior you like. Well, sure, this is kind of special case. If you want to skip every other element, you may do it, but I would say it's kind of a very poorly designed code. You don't want to rely on that particular behavior. I would say if you we really want to skip two, you better use the front until loop and say C.fourth and C.fourth more explicitly. That'll be better. Okay. Yes? C.item over here, basically, C is an iteration cursor, agree? Okay. You can think about C is basically an iteration cursor objects. It's an iteration cursor objects where you can definitely call item. Item is now pointing to some data structure under the hood. Okay, it could be maybe a string. For example, maybe A and also B over here. If you only say C, it's not the string itself. It's only the cursor. But you want to go one more level. When you say C.item, it's now referring to the whatever current position it is. So that will be some string value. So that's the difference. When you say, yeah, C versus C.item, very different. C is a cursor, iteration cursor. C.item is, in this case, string. Okay, good, no problem. Hey, question? Nope, it would just be C.item because you can think it this way. So C is an iteration cursor, okay? Whatever elements here it should be correspond to how the iterable parameter was instantiated. So that would just be a string. So in order for you to get to each string in the data structure, you just gotta say C.item. So that will get to. Yeah. C.item basically say depending on where the cursor is pointing to currently, go to that item. Right? for this case over here, when you say S over here, C would just be an cursor. It's not the element directly. That's why you have to say C.item. Yes, if you use is over here, in that case, the item over here is not a cursor anymore. It's directly the element that's pointing to by the cursor. You can think about reducing one level of indirection. Correct. You don't say item there. Okay, let's see. I think that this example, for the remaining example, will be very similar. Let's just take a look very quickly. And then we solve the exercise together quickly. Okay. So now we got another, so this is our original example. Let's say you got a card class, which is also inherits from Iterable, right? Remember that. And then, so now we can definitely say go across the card, and then every one of them is order. Okay, that one's easy. We have seen that already. And then you got another, I think this one maybe just like a duplicate. So you got bank class, and then accounts will just be iterable. So that means you can call new cursor. In that case, we can use a cross loop, right? In that case, we don't have to worry about the cursor. Just let the across take care of that. Okay. So just understand there are different ways of using the iterator pattern as a client, and be sure you know what you're doing when you choose one way but not others. Okay. Any question about the iterator pattern? Yes. I would say your lab test will be similar to the birthday book example that we talked about. The card example might be a little bit too easy, and the book one is slightly easier than the birthday book. So I would say your best bet is to study all of them to get over prepared. That's what I would suggest. I'm saying for the lab test, the level of difficulty will be similar to the birthday book. Yeah, you should study the birthday book. Yes, that's correct. You have to study the coding. You got to study the design for the birthday book. Yes. You already got the answer for the birthday book, but you can simply empty all the contracts in implementation and do it from scratch. That's what you can do. Yeah. Yes, you can just empty the contracts in implementation and then do it from scratch. Okay, so all the examples have been talked about. Okay, I'm just going to go all the way to, I believe that will be to the end. Oh, okay, sorry, not to the end. Just to the end of the iterator. Before we go on to the next topic, I want to talk about the exercise I gave to you on last Wednesday. Hopefully you got a handout in front of you, right? Okay, if you have already at least have a look at that exercise, so now we can talk about it, okay? So that's the exercise over here. Oh, let me just switch. So that's the exercise you were given, and then I blew out all the things you should really fill in, okay? The way I'm going to do it is this. I cheated a little bit when I was solving the problem, of course. I was trying to find what might be the best, what might be the most logical sequence of solving the constraints over here. So I am going to cheat a little bit when I talk about the example with you. I number the steps over here. Let's just follow them. I thought this sequence would be more logical, but tell me if that doesn't make sense. Okay. Let's try that. So now I'm assuming that you already understand what the classes are. Okay, so we can talk about it right away. Okay, and then you can compare your answer. Okay, so now let's go on to talk about it. To start with, you can see that over here, the first step to look at is you can see this is at the client side. We say DB is of type database, and then we simply say string and integer. Apparently, we're instantiating the two generic parameters for the database class. So 1.1 tells you once you see this, you should go back to the supplier right away and do the substitution. Okay? So now 1.2 is over here. So if I go to database, so now that means G is corresponding to string. H is corresponding to integer. Any questions so far? 1.1 tells you you're declaring the database by instantiating G by string and also H by integer. That's basically what 1.1 and 1.2 telling you. Okay, that was basic. We talked about it in the class as well. Okay, let me move on to the next one. I don't see you at 1.3, so we can go to 2.1 directly. Okay, so now we are still in this particular client side. Okay, and then look at a cross loop. Now, you should be very good in this, determining this. When I go across DB directly, that tells me DB must be iterable, right? That tells me that. And then the T over here, what should be its type, right? The type over here, let's take a look, is simply, what should be the T, what should be the type for T in this case? Yes, something like that. Yes, it should be basically a tuple. Okay, now, what Ray is saying is the T, it seems like it should just be a tuple of integer and string. But now, how did you know that? Which line? Is it in the same class or it's a different class? Exactly, on the tuples, yes. So in order for you to figure this out, you should re-look at the tuples here because if you look at the body of the loop here, the T is added into tuples. So that means T must be an element for that particular collection. And now if you go to the tuples over here, you can see it's a linked list for tuples here, right? And then every element there is a tuple of integer and string. So that's how we figure that out, okay? So 2.1 and 2.2 tells you that basically T here should be a tuple of integer and string. Okay? Okay, after this, let's go back to 2.3. Given that we know T over here should just be a tuple of integer and string, that tells me I could go reverse this time. If I go to 2.3, what should be iterable over here? Tuple of integer and string, right? So that means it tells me tuple of, oh, you know what? There's one more indirection I forgot. Okay, let me do it again. Okay. Now, we know that over here, every element from the DB, the client is going to get access to one element at a time. It's going to be tuple of integer and string. So that should be tuple of integer and string. However, you shouldn't simply just put tuple of integer and string because this is supposed to be a generic class. Okay? So now, question for you. Should I put over here tuple of GH or tuple of H and G? HG? HG, right? Because integer correspond to H, right? That's why 1.1 was really important. And then string correspond to G, H and G, okay? That's why, oh, sorry, H and G. I hope you got this one right. Yes? Of course, if you say G and H, that would be wrong, right? Question?
Actually, for the first one, I don't understand why it's integer string and not string integer. Because DB is
Okay.
string.
Okay. Are you okay with the type for T over here should be tuple of integer and string? Are you okay with that?
That's what I don't understand why it's not there.
Okay, good. So look at this is how we decided. You can see T over here was extended into tuples, right? So that means T must be a valid member type for tuples. And tuples over here is linked list of tuple, integer, and string. So that's why it should be tuple of integer and string.
But then it says DB is a...
Doesn't matter. Oh, you're basically confused about string integer here versus integer string here. They have nothing to do with each other. Nothing. What do you mean the first variable? No, it's not an issue here. Okay, when we declare DB to be string and integer, we have to do the corresponding substitution here. You're okay with that, right? Yes? Okay. And then after that, when you are trying to do this across loop, so somehow T comes from every element you can retrieve from the iterable, right? But what should be the type for T? In that case, for T, is going to be added into tuples over here. And tuple is linked list of tuple of integer and string. So that's why this guy here should be tuple of integer and string. And based on this, we can now say that over here, conceptually, this guy here should be, in general, should be tuple of integer and string. But that's too specific about integer and string. So that's why we should see what integer is corresponding to. Integer is corresponding to h, and string is corresponding to g. That's why we put h and g over here. Okay? Yeah. Yes?
Same question. So E is supposed to be essentially treat an integer, but because it's extends to tuples, it automatically changes integer.
No, actually, though, somehow the t over here, in order to decide its type, the only hints I can have over here is to see that t was extended into tuples, right? So that's why, in order for me to figure out what's the type for t, I need to look at what's the type for tuples. In that case, it's linked list of tuple of integer and string. That's how I figure out, right? That's the only hints I have.
So, isn't T part of V is string integer? Isn't it T part of V? Why can't you look at the V as determine the type?
No, because currently, think about the DB over here is just talking about general types, right? They are simply got G and H, they are generic, okay? On the other hand, in order to figure out the concrete types, you have to look at the client class over here. So that's why I look at the client class first and figure out T in this particular instance should be tuple of integer and string, concretely. And then when I go back to this particular guy over here, I cannot just put in tuple of integer and string, because integer and string is just one particular instantiation for this particular client. In order for me to know, I should really go back to when I first declared DB over here, right? So now I'm saying for this particular client, string would be G, and also integer would be H. So when I'm expecting integer and string at a general level, I should be expecting H and G.
Sorry to elaborate, but I'm still confused. Since because of course DB is a known variable, DB equals string integer. Why are you saying we don't know what it is? Yeah, since it's string integer SI, but
No.
maybe I'm misunderstanding something.
You definitely misunderstand something. Okay, let me try to see if I can help. Okay. Okay, how about putting it this way? A very common confusion goes like this. When you first instantiate DB over here, let me put it this way. How about that? When you say DB over here, you're saying database, and then I say string followed by integer, right? This one suggests nothing about how the iterable over here, where, okay, for example, when I say database over here, I say G and H, right? You don't necessarily have to say G and H in general. You can definitely swap the order. That's my point. So, or let me give you some analogy here. Think about the parameter just like a placeholder. Let's go back to the high school, elementary school math, let's say, right? If you say add, for example, right? So if I say, for example, x and y of type integer, okay? And then I would say define as x plus y. So now it's very common to say the first one should be x, the second one should be y. There should be no rule to stop me from doing this. I can say y plus x, right? Just a little bit of analogy here. So the order that you declare parameters has nothing to do with how you're going to use them. Okay, so here, even though I declare to be G followed by H, it doesn't really mean I should always say G followed by H. I don't have to. That's the main point about this exercise over here. Okay, now think about it. I tell you what, this exercise is quite tricky. And you might ask me, I got compiler, why should I bother with this? Trust me, if you don't have such a notion about compiling in your mind, when you got error message from the compiler in any IDE, not just IFO, you will have a very hard time figuring out what's going wrong. So that's why it's good to really have some logical process over here. Okay, let's go on. Okay. So now we just finished about 2.3. Okay, so now this is the last thing we just achieved. Okay. I believe I finished all the, okay, let's see this. Let's go on to see. You can see for this particular line here, I say iterable and then tuple HG, right? Basically, see this. iterable is basically over here. Agree? Okay. Basically, now I want to figure out what should be the new cursor here. In order to figure that out, new cursor comes from the iterable. Agree? Since I decided iterable should be followed by tuple hg, so that means this particular ge here should be tuple of h followed by g. Are we okay with that? Now, given that g is instantiated by this particular tuple here, that means every occurrence of g is also will be replaced by t of h and g. So that is why this guy here is the answer for here. Is that the case? Yep. Did you get it right? Okay. Oh, one thing I want to say to you, okay? You may have noticed that here, for this particular class here, you can see we got something called G. And for this class here, we also got something called G. The two G's have nothing to do with each other. They simply happen to be called the same name. They are simply local to the class where they are declared. Okay? In some way, we're doing algebraic exercises over here. Okay? Okay, any questions so far? We okay? Okay. Okay, so now we are done with this, and now let's take a look at the iteration cursor. Okay. Now, given 3.1, so we are done up to here, right? So that means for iteration cursor over here is simply tuple of hg, right? So now let's go to the iteration cursor. Okay, you can see the new cursor over here. This particular item here should really correspond to whatever item you will actually return in the iteration cursor, right? That's what we said before. Okay, whatever you return from your supplier for the iterator pattern, it should correspond to the type for the iteration cursor. Okay, that's another gap you want to fill in. Okay, so now after this particular guy here, so that means I really should do the following. G here is really talking about the tuple of hg here. Tuple of hg. Of course, the h and g I'm talking about here is simply the h and g here, right? Just the same, okay? Okay, let me finish this. And then, of course, accordingly, we know that this should be also replaced by tuple of h and g. Any questions so far? Yes? Oh, so here, basically, when I reveal the blue out area, that's the thing you should put. Everything else is only a sketch to help you understand. Yes, exactly. For iterable, you don't change them. For iteration cursor, you also don't change them. I'm just showing you how you can derive the answer. Okay, okay, let's go on to the last bits. So now you can see that over here, the last bit we got is we got iteration cursor in this particular client. It should be t and then hg, right? That's what we got, tuple. And now, what we can do is to figure out exactly how we can do for these guys over here. Okay. Before that, let me say one more thing. Okay. I want you to have a look at the local variable over here for new cursor. You can see for the db cursor, that's going to be dynamic type for the actual cursor we return because we're creating our own class. So it's going to be item iteration cursor, which is referring to this particular class, right? And then here we say h and g. That's something you're given. Okay? So we are saying basically n is correspond to h. N is corresponding to g. Right? Because everything that's within the item iteration class should be in terms of m and n rather than h and g. But to understand which order, you should really understand g and h as well. Okay, so now given the iteration cursor we have, it now should be item and then tuple hg. So one try is, if I simply say, okay, you can see item here and item here. If I simply say tuple of h and g, would that be okay? Well, apparently that's not right because where is h and where is g? They only exist in our conceptual derivation process. But so now that's why I did this particular substitution for 3.2 for you. So now if I want to do for h and g, that should be n and also n. Okay? Okay. So now, finally, we want to figure out this guy here. What should that be? Right? Let's take a look. Oh, this one here, similar. Okay, you just get a tuple. Okay, just follow the same order. I want to draw your attention to a final line over here before we conclude the exercise here. If you look at that over here, and look at this line over here, db cursor.make. Here, I'm basically calling your make feature that's over here. This is where you declare the generic parameters, n and m, right? And we know very well, n over here is really correspond to g, and m over here is really corresponding to h. So now, what should I put over here? If I see, well, conceptually, what I should get is something of type G and something of type H, conceptually. So what do I have over here? Should I say, for example, so I got GS and HS, right? Wouldn't you agree? It should be GS, which is a collection of G, followed by HS, which is a collection of H. Okay? Okay, that's the solution to the exercise. How do you go from this? I would suggest if you more or less follow the same thoughts, maybe not completely, that's okay. You may just want to download the exercise again and try to see if you can follow that process to do it. I would say that's very beneficial for you to do so. Number one, you should realize the way you organize the order of the generic parameter in the class is arbitrary. It's just usually people say G followed by H, but it doesn't have to be. It can be H followed by G. So what we are really doing here is just by logical substitution. That's something you want to get used to. Okay? Okay, any question about this particular exercise in general? Okay, try to do it. If you got more questions, drop by my office hour. I can solve it again together with you, okay? With more details, possibly. Okay, that's about it for iterator pattern, okay? What I would like to do now is go a little bit further about another topic, okay? We're going to talk about, definitely before the reading week, something called singleton pattern. It will just be another design pattern. But today, let's do a little bit preparation for the singleton pattern. I mentioned briefly about the class, the notion called expanded class. You can think about expanded class is like very different from a reference class. In Java, basically every class is like a reference class because when you create an object for the class, you just get the address for the objects, right? But for expanded class, it has some different notion. You just have no sharing. I will get there. Okay? From the modeling point of view, you may just want to make, you may have some particular objects, they should not be shared. They're simply integral part of other objects. Remember back in 2030, you learned about the notion between aggregation versus composition. So composition is when you don't want to allow any sharing. So you have to do something about the copy constructor, right? That's what you learned in 2030. But we got something similar here called expanded class. But the good thing is you don't have to worry about implementing the copy constructor yourself. It will just be done for you. Okay? Let's just see quickly how you can use expanded. So the idea about expanded class is you don't want to share any objects of type expanded class. Now let's see how we can achieve that. Let's say talk about your person lab, right? Basically, in your person lab, you got a network, you got monitor, you got CPU, you got a keyboard. Certain things can be shared, certain things cannot be shared, right? For example, if you look at this diagram here, that's from your textbook, okay? Think about every workstation in the prison lab. Each workstation got their own keyboard, and they got their own CPU. They're not shared. Also, they got their monitor. On the other hand, they all are linked to the departmental network, so that's shared. So when you're really doing your design, you want to think about which part should be shared and which part should not be shared. That's why we got the notion about expanded class. Yes, question? For expanded class, no, it's not going to be in the lab test. No. Check the preparation guide. Yes, question? Right. You okay? You okay?
Yeah.
Oh, I thought you got a question. Okay, so now that's about this particular problem here. Some parts are shared and some parts are not shared. When things are not shared, you better use expanded. But let's see exactly how we can use it. Let's understand exactly the consequence of having to use the expanded keyword, and then we'll see how we can understand a little bit better for the modeling. Okay? So now let's say we still declare classes as normal. We got keyboard, we got CPU, we got monitor, we got network. Okay, now here's the thing. We know that keyboard, monitor, and CPU, they should not be shared for their objects, right? They should be like a composition. On the other hand, network should be shared like normal with aliasing. There are two ways for you to do it. Either you say the following. We have a class called workstation, and then besides the class that you think the object should not be shared, you simply put expanded. And then for class which you believe the object should be shared, you just don't put expanded. That's one option there. Okay, I'll pause a little bit to have a look. If you look at the classes over here, keyboard, monitor, CPU, and network, they're just normal classes. Nothing surprising. However, it's in the workstation class, we have to make some design decision. Since I don't want to share the keyboard, CPU, and monitor for my particular workstation, so they should all be expanded. And the network should be shared, so that's why I don't have expanded.
So, like the ant without network is like the same as global variable in C, and everyone else is like a local or private variable.
Not really about local or private. I think here, when we say sharing, it's really about aliasing, particularly. Yeah, but I'll draw some diagram a little bit later. When you have expanded, that simply means these objects can never be shared for their address. That's one way to do it. Another way for you to do it is like this. And tell me which one you believe is more flexible for us. Let's say this. I simply put keyboard being expanded, CPU being expanded at the class level. You can see the first option there, I put expanded at the local variable, like a variable declaration level. But at the class declaration level, I say expanded class, expanded class, expanded class. And then also network is just normal class. And now when I declare, I don't have to say any expanded type here. Apparently, I got two options over here. Okay, there are two options here. Can anybody tell me which one is more flexible in terms of design? Flexible in the sense that, what if I decided later to say, maybe monitor may be shared among workstation, maybe using AirPlay or whatever, right?
The first one was better.
The first one's better? Why?
So you can say which one you want explicitly when you're using it.
Yes.
Instead of for every case.
Yes. You want to say something? Go ahead.
Not the other way around.
You thought the other way around? Okay, let's see why the other way around is not the case. Okay. If you look at that, let's say I have a change. Every time you want to judge your design, again, think about possible change, right? The change I want to make is as follows. Monitor may be shared. Now, for the first option there, all I have to do is, rather than saying expanded monitor, I just get rid of expanded over here for the first one. So only for individual variable, I just put a modify expanded if they should be not shared. Right? On the other hand, for this particular option here, all I can do is to go for this particular monitor here and then get rid of expanded, something like that, right? So that's something you want to think. But both options work. Just the first one, you only talk about expanded at the variable declaration level. It's more flexible. Okay? But now, what would be the behavior for expanded type? Okay? That's something we want to take a look. Okay? Do I have time? I guess almost time's up, right? Okay, I'll stop here and I'll continue from Wednesday. Okay.